Hey everyone, I'm Rongji, and today I'm super excited to walk you through the brand new embedded WLAN app on the VXG M9484C Signal Generator. We are diving into a live demo focused on Wi-Fi 8, and I will show you how to generate and analyze the ELR PPDU signal format, a key feature in the latest N92.11bn spec. Let's kick things off with the hardware setup. For this demo, I've connected IF port 2 of the VXG-C directly to the UXA N9042B analyzer here. It's a clean and simple setup. Ready to go? We are working with the UHR ELR PPDU format, which is part of Wi-Fi 8. To make this work, just make sure you've got the right licenses installed, listed right here on the slide. Before we jump into the demo, let's quickly break down the ELR PPDU format. It introduces two new fields. ELR-MARK field helps devices detect the signal reliably, even at long range. ELR-SIG field tells the receiver how to decode the frame. These work alongside legacy fields to boost performance and reliability. So what makes ELR PPDU special? It's built for long-range communication, especially at the cell edge. It runs on a fixed 20 MHz bandwidth, supports single spatial stream, and uses BPSK or QPSK modulation with a half coding rate. Plus, it features 4 times frequency duplication over 52-tone resource units for better robustness. Let's zoom in a bit. USIG field includes 3 bits that identify the ELR PPDU format within UHR frame. ELR-MARK field carries a node sequence for detection, includes BSS color information, uses QBPSK on data tones and BPSK on pilots. No power boosting here. ELR-SIG field provides decoding instructions such as modulation, coding rate, frame length, and station ID. It's BPSK modulated, includes CRC and tail bits, and ensures reliable decoding. Alright, let's fire up the live demo. On the VXG-C screen, click the cube icon up top and select WLAN. On the left, go to the Waveform tab. Then open the basic page. In the PHY specification menu, you will see support for Wi-Fi 6, 7, and 8. We are going with N92.11bn, that's Wi-Fi 8. Under generation mode, choose UHR ELR PPDU format, our focus today. You can set the frame idle interval and the frame count to match your test setup here. Next, head to the spectrum page to adjust the oversampling ratio or enable mirror spectrum if needed. In the routing page, pick your IF channel. I'm using group 2 for this demo. Now, let's jump into the carrier tab here. In the general page, we'll stick with the default single stream setting here. On the USIG page here, set the link type, BSS color, and TXOP duration. Want to simulate real-world conditions? Go to the impairments page here. In user setup page, config channel coding, station ID, and modulation index. For ELR PPDU, data modulation is limited to BPSK and QPSK as specified in the standard. We'll use BPSK today, but if you change the MCS index to 1, you will see QPSK kick in. In the MPDU page, you can add or remove data fields here. Set the data length and choose the data type. We'll stick with the defaults. Back in routing page, confirm your output is set to group 2 signal 1. Now hit generate and boom, your signal is live. You will see the spectrum and IQ waveform pop up in the bottom view. Head back to the home page and you will see the signal playing on IF channel 2 now. Just set your IF frequency and power and make sure channel 2 is enabled. And that's it. Your Wi-Fi 8 ELR PPDU downlink signal is now live from RF port 2 on the VXG-C. Let's switch over to the UXA screen to verify the signal. Inside the accepts WLAN, I've already set the test frequency and selected the right radio format, and the signal is demodulated perfectly. Go to the display menu, then the View tab. I've set up a few custom views to make things easier. In the user info summary table here, everything checks out. MCS index 0, BPSK modulation, resource allocation decoded correctly. Here's something cool. Accepts now includes a dedicated ELR-SIG field results table. Just click the date-type drop-down menu here, and you'll find it. From the table, we get LDPC coding, downlink, MCS index is 0, station ID 483. Next, check out the burst info and signal info views. In burst info view table, both ELR-MARK and ELR-SIG fields are decoded as BPSK, each with 2 symbols here. The burst is clearly identified as A02.11bn, running at 20 MHz, using the ELR PPDU format. In the signal info table, we get more on the USIG field. Bandwidth decoded 20 MHz, link type is downlink, BSS color 5, TXOP duration 8 microseconds. Everything looks great. Now, if you are using the N7617C Signal Studio desktop app, you might be wondering, can I reuse my existing settings in the new embedded WLAN app here? The answer is absolutely. Let's back on the VXG-C screen. Inside the WLAN app, click the folder icon here, then choose Import Signal Setup. Find your saved Signal Studio settings file, hit Select, and boom, your setup loads instantly. Head to the Carrier tab and you will see the signal updated to uplink with BSS color set to 10. Let's generate the signal and switch to the UXA screen to verify. Check the signal info table here. Now the frame is decoded as link type uplink BSS color 10. Exactly what we expected. Want to try it yourself? Visit our website and download a free trial of the VXG-C embedded WLAN app. Thanks for watching.